All right, so here we're going to take a look at statements in terms of like mathematical type statement. And what a statement really comes down to is something that can be either true or false. All right, so in the strict math sense, a statement is either true or false. All right, so if we think of, all right, so here's some examples of a statement. So 2 plus 3 equals to 5. That is a statement. Now, these are non-statements. Just to contrast what it would look like if we have x plus 2 equals 7. All right, non-statement because this may or may not be true, right? This depends on x. Right? We can modify it to make it a statement, but as it stands, right, not a statement. All right, so we could, something else, we could say 7 is a prime number. Statement, this is true, right? Verified. 7 is indeed prime. Now, written in this form, is 5 a prime number? Right? This is not a statement, right? That's a non-statement, right? In the way that it is written, right? All right, because here we cannot, we can make it a statement of saying 5 is a prime number, but written like this, right, it is not quantifiable as true or false. All right, we could say there are, there are infinitely many primes. Right, that is true, right, proven, right? That is a statement. All right. Something like solve this equation. That is a non-statement. Okay. Now, excuse me. Here, what we want to get into, what we're going to build towards is having an argument. Now, in terms of, again, what we call an argument, right? Not like you're getting an argument with a person mathematically, right? Mathematically, we have an argument is simply what we call a sequence of statements. Right, something that is either true or false. All right, so here, right, so we have, let's say, statement 1, statement 2, statement 3, however many we have, right? We're going to have up to statement n. All right. So an argument consists here of all of these before the last one up to the last one. These are premises. And the last statement is the conclusion. Right, now what we are going to call a valid argument is when if the conclusion is true, not if the conclusion, excuse me, let me use more. The conclusion is true whenever the premises are true. Okay? So if the premises are true, the conclusion must be true, and this makes a valid argument, right? So let's look at an example here. All right, so here we could say if a number is even, then its square it's even. Then its square is even. All right. So that's our first statement, which is true, all right? Stated without proof, right? Proof of these statements will be later part of the course, but this is a true statement. And then the number n is even. Is even. Therefore, these three little dots here, right, is a math symbol for therefore. So when you see that, we say therefore. Therefore, the square of n is even. This is a very basic example of a valid argument, right? We have statement, 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 right? Statement 1 is true. Statement 2 is true, right? N is even, right? True statement. Right? That means that the square of n is even, right? So this is a valid argument. Okay, so now let's give an example of something that is invalid. Right? So here, if a number is divisible by 4, then it is even. It is even. Right? The number n is even. So that's statement 1. Is even. And then our conclusion here, therefore, n is divisible by 4. Okay, now here, right, notice that the premises of my argument are in fact true. All right, the first statement is true. If a number is divisible by 4, then it is even. That is a true statement. And then I'm telling you, right, I'm making a statement, the number n is even. All right, so that is also true. Therefore, n is divisible by 4. Now we could see here, right, I could say, well, what happens when n is 2? Right, now this does not change the fact of the premises. The premises are still true, right? That if a number is divisible by 4, then it is even. Yes, that is true. Right? The number n is even, 2 is even, but it is not divisible by 4. Right? So here, this is what we call a counter example. Right? And this shows that the argument is invalid. Right? So we could see an argument is invalid when the premises are true, right? But the conclusion, right, can be false, right? And you just need to show it for once, right? Even though that there may be values of n where this holds, right? By showing 1, right, you've made that this to be an invalid type argument. All right? So a couple things here to look out for. I'm going to switch over to our textbook here. This kind of goes over just some definitions here, right? Again, mathematically here. So an argument is a sequence of statements. Okay, so we have developed that, right? The last of which is called the conclusion, and the rest are called premises. All right, and then this is just kind of going over what we just talked about. An argument is said to be valid, provided that the conclusion must be true, whenever the premises are all true. Okay, and an argument is invalid if it is not valid, that is, all the premises can be true, and the conclusion could still be false. All right, that was the second example that we went over there. Okay, now an argument is sound, provided that it is valid, and all the premises are true. All right, a proof of the statement is a sound argument whose conclusion is the statement. All right, now we'll get more on that later, right, in terms of a proof, right, and a sound argument. Okay, now here, I do want to go over just one example in the textbook, right? If Edith eats her vegetables, then she can have a cookie. So Edith eats her vegetables, Therefore, Edith gets a cookie. All right, now if you notice here these statements, right, the premises, all right, if-then statement, right? So this is telling you that if this happens, then she has a cookie, right? Now notice in contrast with that second example there, Florence must eat her vegetables to get a cookie. Florence eats her cookie. Florence gets a cookie. Therefore, Florence gets a cookie. Now, the problem here, so the first one is a valid argument, all right? Because it tells us what are the conditions for Edith to get a cookie. She must eat her vegetables, right? Then that happens. Here, this is kind of sloppy, that second one, in terms of when we have argument-based, right? Because she must eat her vegetables to get a cookie, but it doesn't tell me if that is sufficient information, right? Or as you notice, again, notice the subtlety. The first one, when we talk about Edith, that does. If Edith does this, then this happens. That is missing in that second part. Okay, so as we kind of progress through this class, it's going to be very important the type of language that we use to make our valid arguments. Right? In order to have sound arguments, right, we need to be very careful of the statements that we make and how we make them. Right? We have to tighten up our language.